Good morning everyone. Now let us see about double tuned amplifier. So what are tuned amplifiers? So we are able to tune a particular amplifier by using cue point. So cue point, when it is placed at a particular level, so we can design a particular amplifier by using a tuned circuit. So by using the tuned circuit, we are able to design a particular amplifier to work at a particular set of frequencies. So we have single tune amplifier and two-stage amplifiers are called double tuned amplifier. Now let us see in detail about double tuned amplifier. So this is a two-stage amplifier. We use a transistor Q1. It is having a tuned circuit L1, C1, bypass network R1, R2, and here we have RS, input capacitor C1. So here the tuned circuit has been coupled to the second stage. So hence it is a double tuned amplifier which uses the same set of frequencies. Let us see the analysis in detail. So the circuit description R1, R2 will provide the voltage divider biasing for the circuit. RECE will provide bypass network. L1, L2, C1, C2 together forms the tuned circuit. So this tuned circuit, double tuned circuit is also known as multi-stage amplifier. Each stage consists of two sets of tuned circuit. Each tuned circuit is tuned to a same set of frequencies. Hence, it provides a larger gain and bandwidth. This is an equivalent circuit of two-stage amplifier. So here we have the first loop having the first stage components, and here this is the second stage components. So here we have resistance R11, C1, L1, this is L2, C2, resistance R22, and will be the mutual inductance. From the above equivalent circuit, now we are going to calculate Q factor for the first loop. We know that Q factor is omega R L1 by R11 for the tuned circuit 1. Likewise, for the tuned circuit 2, Q2 is omega R L2 by R22. Output voltage is given by, so here we need to take the output voltage. We have a capacitance here C2. So how do we write the capacitance? 1 by j omega C2. So my V0 1 by j omega C2, second loop I have the current I2. So 1 by j omega C2 into I2. Now consider the modified equivalent circuit. So considering the feedback Zi minus Zf, and this is Z0 plus Zf, and this is the mutual inductance denoted by Zf. This is the modified circuit. So here let us consider Q1 equal to Q2 equal to Q, L1 equal to L2 is equal to L, C1 is equal to C2 is equal to C. So in order to find Q factor, it is necessary to calculate admittance of the tuned circuit. How do we calculate admittance? Admittance is given by Y. Impedance is V by I. Admittance is inverse of impedance, that is I by V. So current in the second loop by voltage in the first loop. V is equal to I into R. Here we consider impedance. So V1 can be written as I1 into Z11. So output by input current I2 by I can write it as current gain AI by Z11. So in general, characteristic impedance of current gain I can write it as minus ZF by Z0 plus ZF. Similarly, the value of Z11, the impedance value of the first loop, I can write it as Zi minus ZF square by Z0 plus Z2. So we know that admittance Y, total admittance Yt is Ai by Z11. Substituting the value of equation 6 and 7 in 5. Substitute here, we get Z0 plus ZL will be getting cancelled. Remaining, I will get total admittance is minus ZF by minus ZF square plus ZI into Z0 plus ZL. Taking ZF common, I get 1 by ZF minus ZI into Z0 plus ZL by ZF. From the modified circuit, characteristic impedance for mutual inductance of coil ZF is given by j omega r k into root L1 L2. Similarly, for coil 1, Zi is R11 plus j omega L1 plus 1 by j omega C1. Similarly, for coil 2, let me consider Z0 plus ZL is R22 plus j into omega L minus 1 by omega C. So calculating the Q factor. Now, by considering the Q factor, Zi value by multiplying and dividing by omega r L1, I get Zi omega r L1 by Q into 1 plus Q2 J del. Similarly, for coil 2, Z0 plus ZL is omega r L2 by Q into 1 plus 2 J del Q. Substituting these values in the total admittance and cancelling out the remaining part, we get, in the numerator we get j omega r k q square into root k1 k2 divided by j omega r square L1 L2 into j k square q square minus 1 by j minus 4 del q minus 4 j del square q square. So taking out the common terms, finally I get total admittance is kq square by omega r root L1 L2 into 4 del q minus j k square q square plus 1 minus 4 del square q square. To calculate the voltage gain, AV is V0 by VI. What is V0? Voltage across capacitance C2. So 1 by j omega r C2 into I2. So we know that I2 is total admittance value Yt into V1. So we know the value of total admittance into V1. So we have found the gain value. Substituting the value of total admittance, we get equation number 20. Hence now we are going to calculate the bandwidth. So general bandwidth, we know that lower cutoff frequency is Fr into 1 minus 1 by 2q into root of k square q square minus 1. Similarly, for higher cutoff frequency is given by Fh is equal to Fr into 1 plus 1 by 2q into root of k square q square minus 1. So hence we can find bandwidth as Fh minus Fl. It comes to Fr by q into root of k square q square minus 1. So taking the value for 3 dB, my value of bandwidth at 3 dB comes nearly 3.1 FR by Q. So this is about the double tuned amplifier. Thank you.